I kind of made a bad title for the talk. I think a better subtitle is how to compile mutually recursive modules without HS boot files. So that's sort of going to be the main lead up to the talk. It's this bug, if any of you have seen it. Some of you maybe subscribe to it. It's a really interesting bug. So let me fill people in who haven't heard about this before. So the problem is sometimes you have modules which import each other. A imports B, B imports A, and GHC is like, I don't know what to do, I can't deal with this. So the bug report is maybe GHC should be able to do something by default in this case. And there are many reasons why people don't like this state of affairs. HS boot files are a nuisance. I absolutely hate writing signatures. I waste too much time fixing import cycles. Oh my god. So I definitely sympathize with some of these concerns, but it's kind of not. It's a double-edged sword. So Simon 6 years ago wrote a comment on this, and he said, well, writing HS boot files is like writing signatures in ML. And, ML people will tell you, that's really good. You should write signatures for the modules you depend on. Why is everyone so against it? And the other problem was that, there's not really an obvious way how to go about solving this circular HS boot problem. And there hasn't been for a while. And one of the reasons is because okay. So there are two ways you might go about trying to solve this problem. The first is to say, well, I have a bunch of Haskell files. They're in some sort of cycle, but actually, I should treat them as if they're, one giant module. I just include, put all the source files in the same, source file, and then have GHC compile it in one go. And the other way to go about doing this is to somehow make it so that GHC can automatically infer HS boot files. So for the longest time, the discussion on this ticket was about doing the first strategy, right? Because it's sort of people write mutually recursive definitions in Haskell files all the time. And so that's why sort of this mutual recursion at the module level is something people might find desirable. But there are problems. So first, the good things. The good thing about this strategy is that you'll get the best performing generated code because if module A refers to something from module B and that can be inline, that will be inline, and module B refers to something from C and that's also inlineable, that will be inline. Whereas with HS boot files, you can't inline across a source import, so their inlining is not possible. But there are some big problems with compiling strongly connected cycles of Haskell modules as one unit. For example, once you change one of these Haskell files, you have to rebuild everything that is involved in the cycle because you were building it as one monolithic unit. Why are you putting them in separate modules in that case? Maybe because you want the namespacing mechanisms, but maybe then we should introduce a namespacing feature to Haskell instead. And a closely related issue is how do you compile a single Haskell module when they're participating in one of these giant loops? What does it mean? You have to know about the cycle before you can actually compile it. So sort of kind of complicated, unclear, how to actually go about implementing this. So, Simon, described some things we could do, but really, this fell by the wayside. So the other implementation path, I think, is if we can somehow infer what an HS boot file is. So something people often say when they're complaining about having to write HS boot files is, well, I wouldn't mind so much if I didn't write type signatures in my Haskell files. But I do write type signatures in my Haskell files. I religiously, annotate all of my top-level declarations with, signatures. So I don't want to have to copy-paste them into some extra HS boot file, which then tells me what's going on. And so, you might imagine that there should be some way of just pulling out the signature from the actual module in question, assuming that someone has written all the types in question. Of course, if we're still using HS boot files, we can't inline, but Norman might say that's a benefit because now if I change the implementation, I don't have to recompile in that case, which is really nice for compile times. What?
Why not?
You don't cases when that's useful. And, but there's a big problem, which is what is the actual hsboot file you are going to infer? And let me explain sort of a little more in detail what the problem is. So here's our sort of very classic mutually recursive module. We have a data type A and a data type B, and they rely on each other, and some functions which refer to things from the other module. And I've written explicit type signatures because this won't work at all without them. So let's say we want to infer the hsboot file for B. So we need to somehow write down all of the things that are being used in our file. They've been highlighted in red. So we need the type B, and we also need the constructor mcb, because those are the things that are referred to in A. So we might say again. How did I know? Well, okay. The actual implementation is just going to try to do as many things from B as possible. But I haven't gotten there yet, so sorry. Yes, can I answer that question in like 5 more slides? Okay, so let's suppose that we know what things we need. Let's try writing them down. So we say, okay, I need a data declaration B, and I need a constructor mcb because it's referred to there. Okay, so what's the problem with this definition? A is unbound. What does A refer to? Oh no. So, and if you've ever written like a very complicated, like if you're a GHC developer and you've looked at the hsboot cycles that occur there, hsboot files have to sometimes import hsboot files. And it's all very kind of, delicate and finely balanced and, oh my god. So what are we supposed to do? So let me tell you the answer. The answer is stratification. So basically, I want to make a comment about the sort of types of declarations that are in modules. So in module A, we have a bunch of different types of things. So we have value implementations, which are basically x equals and then some number of constructors and variables and other good things. And we also have data type declarations. And these implementations and data type declarations refer to values, constructors, and types. But now let's suppose we go up one level and we consider hsboot files. So hsboot files define many of the same things as Haskell files, but they only talk about signatures of values, not the actual implementations. And the data types, well, the data types are the same as in Haskell files. But notice that this means that at the references level, we only refer, in the signatures, the type signatures and the data types, we only refer to types. We don't refer to values or constructors. So the way that we can break this Gordian knot is by introducing another level of hsboot files, which only defines abstract types, and these abstract types refer to nothing. Of course, if you're, someone who uses kinds, you'll need a third level for abstract kinds. But the point is that, if you go up far enough in this hierarchy, you will not have any more references, and the import problem goes away. So perhaps I mistitled the talk. I started with, look, no signatures, but actually the way you solve the problem is by adding more signatures. So there's a lot of code here, but basically I've written down a plausible implementation of hsboot, and at the very top level, I just have abstract type signatures. So if we look at the references, module A refers to B and mcb, which are defined in hsboot. And hsboot for B just refers to A, which is defined in hsboot 2 for A. And so we don't have any cycles anymore. We just have the spirals upwards in the hierarchy of hsboot files. Okay, so now I need to return to Simon's question, which is Simon asked, but how do I know what things I need to put into my hsboot files? So the plan is that we are not going to make a guess. We are just going to put everything we can into the hsboot file. So the plan is you'll continue to have to break import cycles with source pragmas. This will just say where where does the inlining fail to happen? Like where are we going to move up into the HS boot hierarchy? And then if you didn't write an explicit HS boot file, because we want you to still be able to explicitly write these things if you are a red-blooded MLer, then we can generate an HS boot file by looking at the Haskell file and erasing all the value implementations. And then for every module in the strongly connected component, well, the module cycle, we generate an HS boot file, file, saying what the abstract types of the, just containing the abstract types, which our HS boot file might refer to. And that's all. That's all the extra things. So you could imagine like writing these to disk, or better yet, just keep them in memory because you don't want to clobber any existing HS boot files. Right. So you have to explicitly break import cycles, and the imports in the. One other refinement. If the HS boot file you generate refers to an import that is not in the SCC, then you can just make it a normal import because it's guaranteed not to be participating in the cycle. Okay. I want to just open up the floor for questions real quick. Yes?
So in simplicity with an HS boot file, if the source file said, I know, data B equals muck B of A, where did that A come from? You were kind of implicit, assuming that you knew which module it came from. So in this case, how do you know it came from module A?
Yes. So the answer is,
You have to process the
I have to process the cycle to figure out where everything is coming from before I can actually do this process. As a strongly connected component.
So you do need to read all of the modules that are strongly connected and get as far as the word renaming.
That's right. I have to get as far as renaming.
You just don't have to go as far as type checking.
I don't have to go as far as type checking.
Okay.
Which those of you who may have the name first name Derek and the last name Jerry may recognize this step as the shaping pass that occurs when you are doing mutual recursion in module systems. So it seems unavoidable to some degree. Yes.
What happens when you have data separation or enriches the independent Haskell bus?
Oh yeah. Why don't I go there? Warning! Merging types with kinds. So what do we do? The big problem is you may need arbitrarily. So I think actually having arbitrarily many HS boot files is okay. The real problem is you're not writing them. It's just a internal abstraction in the compiler for how to deal with it. Like if you just say, oh, there's just a hierarchy of HS boot files, it's not even that much code. The real problem is you need to figure out before you do any type checking how far up you need to hoist each of these declarations. And that is not immediately evident because when you merge types with kinds, that you lose the stratification. So my suggestion is you should mark what the max level is, but it's not good. Yes?
Can you just try only having one level and then everything else is two?
Yeah, I guess you could do that too.
This is a useless observation, but I want to click on it. If you look at the fact that you have cycles, and then you go up a dimension, so to speak, and then you sort of have less cycles, and then you go up and it disappears. Right, mathematicians have a name for this in homology. They call this the chain condition of a co-complex or a complex, and I think that is actually what is going on here. I don't know what to do with that. But the boundary is zero is sort of the exact thing that's going on. You've got some sort of chain complex, and somebody do something.
I guess I feel slightly enlightened. Other queries? Yes?
Have you ever heard of anybody needing more than 10 levels of universe hierarchy?
Maybe? I hear it shows up a lot in independently typed programming.
I've never seen more than 5 of them. So if you set it to 10, then you'll be
Okay. But wait, there's more. So this set of slides is why it's kind of related to Backpack, which is that, sort of this idea that we can hoist out an HS boot file from any HS file means that every implementation of something also implicitly defines a signature, which represents what is being implemented. So if we so wished, we could take, I apologize for people who are not completely up to snuff with their backpack syntax, but this says, please take the concrete implementations from my library and use them in my program. And you could write an explicit hsboot file to sort of remove your dependence on the library. But I propose that we should introduce a new construct to Backpack called require, which says, please do this hsboot inference on my lib and use the required interface as the thing that I need.
That just seems like a weird name. Why not interface of?
Interface of, okay, we could rename it to that. Yeah, I guess I did too much PHP back in the day. And, so there are a few things that you have to adjust. For example, if you don't use a value or type from one of these, inferred interfaces, you don't really want it to count towards your requirement. And also, there's some funny business with type identity, and I'll make a claim without justification because I don't have that much time, that hsboot2 files should not influence type identity. Sorry. Yes?
So you've got two separate things going on here. One is the kind of inference bit to write HSBoot files, and the other is to have a stack of
Yes,
HSBoot files to put into the
that's right.
Now, at the moment, GNC actually is in the wild, has neither of these. Why are you introducing two things? Couldn't you just have introduced a way to write HSBoot files, having done your shaping thing, and just use what you have today? In other words, is somehow this stack of different HSBoot files important to what you're describing?
The stack is important because when you want to infer, you don't have a good place to put the A, right? So when you make it a stack like this, there is a place to put it, which is where the correct level of the original module which defined it.
Now that when you want to say, the HSBoot file for B, for module B, says I'm referring to A, right?
Yes.
Because they've got a B of A,
That's right.
right? So, and you're telling me that after this, after you look at the strong kinetic parameter, you know that A comes from module A.
That's right.
Very well, so it comes from the HSBoot file for module A. Why would you need an HSBoot file too? I don't see what's gained. After all, you've got a data A there. It's going to be there because it's one of the things that is defined. But that will work today. I mean, that's what happens today. I just don't see what you're gaining out of today. You say it's a new level of expressing, that's what you can't express.
So the hsboot2 file is a sort of useful convention to make it possible to refer to A in a basically this is like a syntactic verification of what's going on in the compiler. And I could imagine the way that we would implement this is to run shaping, not bother with hsboot2 files and have everything just be wired up correctly. You still have that kind of annoying thing, which is that the tie things that you make for A are kind of not going to be the thing you want them to be, right? So yeah, it is kind of circular even in the compiler.
So the nice thing about this is that there are no cycles anymore.
Yes, there are no cycles anymore here.
Refer now to source 2, there will still be a cycle. I don't know if that matters or not, but here it's quite clear cycles are gone.
Yeah, you'll probably have to explicitly say it. I mean, if it's star, we can assume that it's star by default, which is what happens. Yeah, so better start annotating your kind. Sorry. Derek had a question too.
This is reminding me of the way that recursively dependent signatures are formalized in the original paper was they explicitly in the type checking of a recursively dependent signature, which is what you I guess is would be equivalent of not the HSP that's written here, but what Simon just used.
Yeah.
Basically the semantics of that is defined exactly in terms of pulling out what was called first of the signature, which is your HSP2, and then you type check the body of the signature, given that it's recursively as the HSP.
Okay.
Just a reference.
Makes sense. All right, I'm out of time, so thanks, guys.